actually get faster than 300 miles per hour. That actually inside.
Could be. Yeah, that's one of the things is scientists are still gathering data on tornadoes.
Yeah, that's what someone just asked me. They're like, how are tornadoes even, like, why do they even happen? And I was like, well, we're getting ready to learn about them in meteorology. They're like, I think they're still trying to figure it out.
Yeah, they are. There's some things that they know, but some things are just still not. The problem with tornadoes is it's hard to know on a small scale what the weather event's going to be. It's hard to know where your instability will lead to a thunderstorm. And then it's hard to know if that thunderstorm will go ahead and give you conditions for a tornado. So here's some general things about a tornado. They are a big old L at the Earth's surface. Surface low. That's weird.
You said excuse myself, and I'm like, okay.
Tornadoes can be short in duration or long in duration. They can kind of take different shapes. So this one is kind of ironic. We got the whole rainbow, yeah.
Oh. Is that real?
Yeah, yeah.
That's crazy. Oh my god.
And there's another one. I know that this is like a rope, you know, they have different names, a rope shape and then the wedge shape. I'm not sure what that would be. But so this is a table from your textbook, just kind of summarizing some interesting facts about tornadoes. Here in a minute, we're going to see where do tornadoes occur in the world, and we're going to see that the United States gets most of the tornadoes that occur worldwide, but the worst tornado ever for taking lives actually occurred in Bangladesh. That's a lot of people in a single tornado.
I'm surprised Joplin isn't on there. This might be an overlooked.
It could be.
That makes sense because I don't know if the structures down there are as sturdy as.
Yeah, that's true. One of the things about fatalities is it's not just the event, but it's kind of the how people have, yeah, what their structures are like. So.
My cousins live in Joplin, and they weren't affected by it, but I went like a couple weeks after, and it was just like, it was devastating to see like the ground just
flattened.
Everything was gone.
Yep, I cannot imagine.
It was just breathtaking. I had no idea what to say. It was just crazy.
I cannot imagine. I cannot. This is from the tri-state tornado, and you talked about flattened. This was one of the deadliest. Now, 1925, actually structures are better now, but also warning is a lot better now. So, I don't know with the Joplin tornado, did they have much warning? I can't remember.
I don't know. I think like they said it was going to happen, and then it just happened all of a sudden.
Okay.
So.
Kind of no general timing,
Yeah.
but not when.
I can't believe that tornado was on the ground for that long.
Yeah. Yeah, that's a long path for it to be on 40 minutes.
Oh.
How many miles was it?
I don't know. Long time, long span. 3 states, tri-state. Okay, so yeah, we're still trying to gather the science on tornadoes. We know that, like I said, L not as in loser, but L as in a low pressure. So basically, when you think of the eye of the tornado, which is actually the vortex, you think of a low pressure down there, central low pressure. To have tornadoes, if that's your goal, you need to have thunderstorms, thunderstorm cells. You need to have unstable air, like we've been talking about earlier in the class. So how do you get that? You can have a front, lifting warm, moist air in front of it. Squall line, remember that was one of our 2 multi-cell storm systems. Mesoscale convective complexes, MCCs, that's the blobby thing. Okay, supercells.
Telling squall lines, the tornadoes would be like rain wrapped.
Supercells would be rain wrapped, but squall lines can sometimes, squall lines are just like normal thunderstorm cells, just kind of, lined up all along the front. The next chapter, we're going to talk about hurricanes. A name for hurricane is a tropical cyclone. So hurricanes are easier to chase. They're more understandable, hurricanes are. But even within a hurricane, we can have tornadoes drop down from a hurricane. Like, really? The hot times for tornadoes are between 3 and 8.
What?
Yep, 3 p.m. to 8 p.m. Now,
Oh.
yeah. But now there are nighttime tornadoes. And actually the nighttime tornadoes are the most dangerous ones, obviously. Yeah, you can't see them. Your best bet to see a tornado at night is if it runs into a power line. And you're like, oh, there it is. So,
Random explosion.
yeah, random. So, some pictures of tornado damage.
Oof.
Yep. Just happens so
It's weird, that
fast.
truck was tossed into the small cars, not even touched.
It seems like pretty random
Very
sometimes. Like this guy's okay and this guy is not so much. Yep. So
Same
there's
truck is
Washington. Yep. Washington, Iowa. Or Illinois, excuse me. Washington, Illinois. Yep. And this is in November, which is kind of late for tornadoes. Yeah, it is. And this is the Moore, Oklahoma. I mean, that's a lot of lives. A lot of people. When I look at the damage, sometimes I'm amazed that the few fatalities that there are.
That's fortunate.
It is
Do you know
fortunate.
the fatality in Moore, Oklahoma?
What's that?
Do you know how many people?
I don't
lost?
have that handy. In Moore, though, it was if you've heard F5, F5 is the strongest tornado. Now, instead of the F scale, the Fujita scale, they have the enhanced Fujita scale. So instead of F, now it's EF. It's kind of why? Because they took a look at it and they decided they needed to tweak it. Tweak it, yep. You know, scientists.
Oh boy.
So if the tornado doesn't reach the ground, they call that a funnel cloud. So kind of a little distinction there. The reason that you see a tornado is because it's picking up debris, like cows, right? No. Because it's picking up debris. But the other thing is it could just actually have like cloud particles, which cloud particles are like condensed liquid water, okay, like cloud. That could be part of making your funnel visible. Yeah. Since I said they have a big old low pressure at the bottom, they should be going counterclockwise. So if you're looking down at the tornado, go like this. Counterclockwise, should be. Okay. And they generally travel from the, and this was something I think Cassidy took exception, but they generally go from the southwest to the northeast, generally. And that's why one of the videos I think we looked at, the safety video, said if you are in a house, okay, do not go here.
In the south.
Yeah, I think you should go to the north. I think east corner grass, northeast corner grass.
What if you don't know direction?
If you don't know direction, get basement or bathtub, center part of your house. Yeah. So
My dad said that if tornadoes wouldn't hit here, so.
Because of the river, right?
because the
That's
river.
what I heard too.
A tornado probably wouldn't climb up the bluff.
Have you ever heard that story?
Chief Keokuk,
Chief Keokuk,
stop tornado.
yeah, he said there wouldn't be any in Keokuk.
Stop tornado.
The topography though really could be. I'm not thinking Chief Keokuk as much as
But
the
you-
bluff or the river.
You said
Yeah.
tornadoes can go on water, so
Yeah.
why wouldn't we get
They
tornadoes?
generally don't though, they like skip over. Like, don't they?
They don't skip
Yeah.
over
Water spouts.
water, but you
think
figure
it
water
stops
might,
over.
the temperature might not, they wouldn't form over water, they would move over water, I would think.
They move on over water?
Water
Yeah.
spout.
So that means that a tornado could happen here
Yeah,
if it went across the Mississippi,
yeah.
which would be like in the history of the globe. Because I don't think that's happened before, has it?
Remember, here, maybe this will help. In order to get a tornado, you need to have a mesocyclone, basically, and I'll kind of show you this here in a minute. Hold that thought.
Okay,
Hold that thought.
all right.
Okay, so before we talk about that, there are this, the middle part of the tornado is called the tornado vortex, okay? And this actually shows you what the pressure is like, okay? So basically I have that very low pressure, okay? And then this is actually, as you go out, this is in This would just be, it says seconds, but, because it's moving. But as you go a little bit from the eye of the tornado, I know it's not an eye tornado, then the pressure goes up significantly. So basically you have a really steep pressure gradient from the center of the tornado outwards. So steep pressure gradients can bring you the strong winds that, like we saw in that video. Now it's possible that your central vortex can have multiple suction vortices. And the next figure actually is a picture of that.
That's
So you, yeah, you have your central tornado with the central low, and then you have this kind of fingers going out. And it looks like this. This is really creepy, I think.
Ooh,
I know.
you wouldn't know where to go. They're everywhere.
But to me, this almost makes sense when you look at some of the devastation of a tornado. It's not just the main vortex, but it's these multiple suction vortices that go along with it.
Freaks me out.
It does. It is kind of freaky. I know. So yeah, still kind of ongoing. With regard to lightning, there's some debate about that whole thing, and there's also a debate about kind of the science behind tornadoes too. They do debate about everything. Do you remember the other day when we talked about like majestic versus tilted cumulonimbus clouds? Okay, so majestic was straight up, and we said that there wasn't much wind shear. And then the tilted ones come from a significant amount of wind shear. Well, like the slide says, it's thought that if you have the tilted cumulonimbus cloud, it's kind of showing you the wind shear as you go up, that's a possibility that you could go ahead and get a tornado from that system. So only 1 in 100 thunderstorms will give you a tornado. It's kind of low statistics.
Is it true?
Is it true? Yeah. Rounded to one significant figure, that's pretty true. Hail, remember, is another thing that triggers a severe weather alert. And your hail shaft will be in the vicinity of where you're, the busy part where you're maybe going to get a tornado.
So it's not good when I get hail. 'Cause
Yes,
could-
if it hails. Now, just because it hails doesn't mean you're going to get a tornado,
Oh.
okay?
So they always say like
Yeah.
green skies before.
Yeah, I've looked into that a little bit. The whole green skies, actually that kind of has to do with kind of the time of year and kind of the, but I know, you feel the sky
It
kind of
smells
change.
weird too, like when, yeah.
It does. So this kind of goes back to, I think, why in this region we're less likely to have tornadoes. Remember, we talked about supercells and we had that, whoa, the mesocyclone in the middle of a supercell? Okay, this is how do you get that mesocyclone there. The mesocyclone in the middle of a mature thunderstorm cell, that's where your tornado is going to drop down from. That's one of the thoughts. So that mesoscale that ends up being kind of upright actually started out horizontal instead of vertical. So to me, we talked about wind shear. You need your wind shear to basically get a rolling chunk of air, okay, that ultimately is going to be stood upright by some upward motion, stood upright. So it starts out like this, it gets poked up, and then it goes like this. Okay, and that is your mesocyclone in your supercell. Yeah. And so notice that we have the tornado. I don't have a good example of a wall cloud there, but dropping down from your mesocyclone.
Oh, wow.
So it's almost like this one posed for that. And you might think, well, that's a funnel cloud, but if you look closely, actually, you can kind of see some dust being kind of brought up from
It's going to touch the ground.
yeah, I think it is touching the ground, yeah.
Oh.
I know. It's like, oh. Yeah, gray, not related to tornadoes or anything, but the color of the cloud actually is an indication of kind of how dense it is, how packed full of water, condensed water it is. So dark clouds creep us out for a reason. Basically, you have a lot of condensed water there that's blocking all the sunlight.
Do they absorb it and spit it out someplace? Or
They absorb it and don't spit it out,
Oh.
yeah. It's called multiple scattering. Basically, the light enters, and if there's all sorts of condensed water, cloud particles, it basically scatters, and does not come out internally, yeah. It just gets absorbed, it loses its energy by kind of going back and forth, yeah.
Oh, okay.
Where does it go? That's a good question. So this is kind of another figure. If we talked about updraft and downdraft. First off, what do you guys think? Well, let me draw. Go ahead and draw an updraft and a downdraft. What stage is that thunderstorm in?
Mature.
Mature, very good. And we talked about an anvil. What makes an anvil? What's it bumping up
Oh,
against?
the top of the triples.
Top of the troposphere or the tropopause, you're both right. We call these overshooting tops, same thing. They call them penetrating tops on this figure. Very good. So, like I said, your tornado, if it's going to form, may be in the vicinity of where your hail shaft is. Okay. So this is a pretty good example. Can you see kind of the little bit of where I have purple there? Where I have purple, that's your wall cloud. So it dropped down from the base of your cumulonimbus cloud.
It's crazy how big the cloud is and how small the tornado
It
is.
is. It puts perspective on the tornado, yeah. And-
then you see what they do, and you're like, oh.
I agree. I agree. Okay. So we were just talking about this, tornadoes. Where do they form? How many slides do we have left?
Page 25.
Oh my gosh. Okay, yeah, let's just hold this thought. This is a good way. We're kind of segueing into something else. So, sorry. I promise we'll get through this chapter on Monday. And then we'll go ahead and start hurricanes on
I know
Monday.
sometimes the storms split in this area.